Let's look at some improper integrals. So I'm just going to get a new page. And first of all, I'm going to look at y equals 1 over x squared. So y equals 1 over x squared. And I'm just going to concentrate on the positive side. So if I just change my start to 0. Okay. That's my y equals 1 over x squared. So if I just bring it over here. Now what I'm interested in is the area from 1 to infinity. And I want to know, is it undefined, is it infinite, or does it converge to a limit? So if I select my curve, and then if I go to Object or right-click, Create an area. So my start point is 1, and my end point is A. So we go, okay, nothing's happened there because the starting value for A is 1. So if I change that to 2, I've got an area. So if I go to my calculator and I want the area, and then if I write area for 1 over x squared, and if I use the keyboard and use the square there, move that away, and then equals, and then OK. So now I'm going to increase my A values. If I do my step size is step size 10 and go up a little bit more quickly. So we're looking to see, does it converge or does it go up to infinity? Is it undefined? Now it's looking like it's going to converge. And in fact, it looks like it's converging to 1. In fact, if we do the algebra, it does converge to 1. So we've got the area under y equals 1 over x squared from 1 to infinity does converge to 1. So let's compare that now with y equals 1 over x. So y equals 1 over x. And if we think about that, when x is 1, 1 over x and 1 over x squared is the same value. And then what happens as x is bigger than 1? Is it going to be above or below? So we can have a think about that before we plot it. So if I plot that, we can see it's actually above, so it's a little bit bigger. So the area between 1 and infinity is actually going to be a little bit bigger than 1. So again, is it going to be a finite value? Does it converge to a particular value? Or is it infinite? Does it diverge? So if I just take the first one, I'm just going to hide that, and then we'll look at 1 over x. So if I go to Object and Create an area, again, start point is 1, and this time I'm going to go to a point B, a variable point B. So if I then go to my constant controller, change my B to, let's start with 2. And then if I go to my calculator, I want the area. And then we've got area for 1 over x is equals, and then OK. So now I'm going to change my B value, and I'm going to do a step size of 10 again. So if I increase B, now this time it does look as if it's getting bigger and bigger. So if we just change the step size a little bit, I'm going to go up in thousands this time because it's quite slow to increase, but it does seem to be getting bigger and bigger. It doesn't appear to be converging to a limit. So I'll just increase that even more, and we can see that we're getting very, very big now. So we can conclude there that we've got a divergent area, that it doesn't converge, that it's infinite. And then if we think about 1 over root x, I'm just going to hide that as well so that we haven't got too much on the screen. So if we think now about 1 over root x, So I'm going to put that in. So y equals 1 over, and we've got a square root here, root x. Again, when x is 1 over x and 1 over x squared will be the same. And then what happens when x is bigger than 1? So we can think about that before we plot it. If I go, okay, it's actually bigger, so it's above. So again, if 1 over x from 1 to infinity is divergent, doesn't converge to a limit, then it must be true also for 1 over root x, because it looks like the area is bigger because the curve is above. So if we try that, so go to Object, Create, Area, and we're going to start at 1, and this time I'll do D. And then again, we need to change the D to another number. I'll put it as 2 just to start with. And then we can go to our calculator. We want the area of that. And then we've got area of 1 over. And I'm going to use my calculator, sorry, my keyboard for the square root there, and x, and not forgetting equals, and then OK. Let's move that out of the way. So now if we can change the d, so I'll do step sizes of 10 again. Now we're expecting it to get big and approach infinity. In fact, it is getting bigger more quickly than previously. So if I just do some larger step sizes, just so we go up a little bit more quickly, and we can see that it is diverging. It's getting a lot bigger now. So it approaches infinity.